you're here, which means you're ready to go deep. Today, we're tackling a question that pops up for, well, pretty much anyone thinking about building something online. How do you actually build it?
Yeah, what are the nuts and bolts?
Exactly. Specifically, we're diving into the different technology stacks you could use for an online ebook application. Like a platform to discover, buy, and read digital books.
And we've looked at a range of ways to do this, from, let's say, the more traditional setups to some really modern integrated platforms.
Right. So our mission here for this deep dive is to really understand the core pieces, the components, and maybe the trade-offs of these different tech stack options.
The goal being you can grasp the different ways an app like this could actually be built.
By the end, hopefully you'll have a much clearer picture of how these things come together.
Yeah, and it's really important to stress, there's no single best way. That just doesn't exist in tech, really.
Good point.
Each stack offers a different toolkit, different assumptions about what matters most. Speed, control, scalability.
Understanding those differences, that's what we're aiming for today.
Couldn't said it better.
Okay, so let's jump right in. First up, what we're calling the classic containerized stack. This is probably pretty familiar to a lot of developers.
Oh, definitely. Still a very common, very robust way to build web apps. Think of it like building with separate Lego blocks, kinda.
Okay, so break that down. What are the main blocks here?
Well, you've typically got a clear separation.
Yeah.
There's the front end, what the user sees and clicks on. In our example, maybe that's React.
Right, handling the UI, the interactivity.
Exactly. And then on the other side, completely separate, is the back end.
Yeah.
That could be, say, Node.js using the Express framework. It handles all the logic, the data, the stuff behind the curtain.
And that separation is key here, isn't it? React just focuses on the presentation layer.
Precisely. Makes it really good for dynamic interfaces. Meanwhile, Node and Express are managing user accounts, maybe processing book purchases, organizing the library, all that stuff.
And teams can work on both parts kind of independently?
Often, yes. Which can be efficient. But, and this is the important part of this approach, because they're separate, you have to pick and connect all the other necessary bits.
Yeah, right. Like the database, where all the book info and user data lives.
Yeah, you need to choose one. The sources mention options like PostgreSQL, which is a relational database, or maybe MongoDB, which is NoSQL. Another decision point.
And what about logins, user security?
Authentication, yeah. You'd likely need to implement something. JWT JSON Web Tokens is a common approach mentioned. Got to handle that yourself.
And the actual ebook files, where do they go?
Another choice. You need object storage. Maybe Amazon S3, maybe DigitalOcean spaces, or something similar. You select it, you integrate it.
So it's very much about picking individual components and stitching them together.
That's the essence of it. And this philosophy extends to deployment, too, getting it online.
How does that typically work here? The sources mentioned Docker.
Right. Docker containers are super common. Think of them as little boxes that package your app code and all its dependencies, so it runs the same everywhere.
Okay, so you package the React app in one container, the Node app in another.
Usually, yeah. And then you manage these containers, often with a tool called Docker Compose, running on a Linux virtual machine, a VM, maybe from DigitalOcean, AWS, Google Cloud.
And how do people actually access the app? Through a web server?
Correct. You typically put something like Nginx or maybe Caddy in front. It acts as a reverse proxy, takes incoming requests, routes them to the right container, handles HTTPS for security.
Gotcha. And keeping it updated. Manually logging in seems tedious.
That's where CI/CD comes in. Continuous integration, continuous deployment.
Using something like GitHub Actions.
Exactly. The sources mention that. So a developer pushes code, GitHub Actions automatically builds those Docker images.
And then pushes them out to the VM.
Often using something secure like SSH to connect to the VM and deploy the new versions. It automates the whole release process.
Wow, okay. It sounds like you have an immense amount of control with this setup. Every single piece.
You absolutely do. That's the defining characteristic, really.
Right.
Maximum flexibility. You can pick the absolute theoretical best tool for every single job. Fine-tune everything.
But there's a catch, I assume.
There's always a trade-off, right? That freedom comes with, well, significant responsibility.
Meaning?
Meaning you manage the integration, you manage the scaling, you handle the updates and security for each component, the database, the server, the storage, the Node app, the React app. It's all on you or your team.
No single help desk line to call if the whole thing breaks.
Pretty much. You own the whole stack, top to bottom.
Okay, so that's the build-it-yourself high-control world. Now, let's take a sharp turn. The Next.js plus Firebase stack, this sounds quite different.
It is, yeah. We were stepping firmly into the realm of BaaS guys, backend as a service.
Yes. Okay. So Next.js is still there, right, for the front end?
Yep. The sources highlight Next.js 15 using React 18 TypeScript, a modern front-end setup. It can even handle some back-end logic itself with things like API routes. But the real game changer here is Firebase.
Right. Firebase isn't just one thing, is it? It's like a collection of services.
Exactly. It bundles together a whole suite of back-end tools that you'd otherwise have to build or integrate yourself.
Things like?
Well, Firestore for your database, a NoSQL, document-based database, Firebase authentication for handling user sign-up, login, password resets, all that, and Firebase storage for, storing the ebook files.
So it replaces the PostgreSQL, MongoDB, the JWT stuff, the S3 spaces from the last example.
Largely, yes. It provides those core back-end pieces out of the box, all managed by Google.
And the sources suggest this really speeds things up.
Dramatically. Often, you're not spending cycles setting up a database cluster or configuring an auth system. You just use the Firebase services via their SDKs.
And they often have features like real-time updates. Could that be useful for an ebook app?
Potentially, yeah. Maybe for showing live reading progress if multiple people read the same book, or for notifications or social features. Firebase makes that kind of thing easier.
So the aha moment here is really about development velocity, maybe. Getting something working quickly.
Absolutely. If your main goal is validating an idea, getting an MVP out fast, maybe testing the core reading experience without getting bogged down in infrastructure, Firebase can be incredibly powerful.
But are there potential downsides? Like maybe Firestore isn't right for every kind of data.
That's a fair point. If you need complex relational queries, like you might do with SQL, Firestore might feel limiting later on. You trade some flexibility for that convenience.
And deployment. How does that compare to the Docker VM setup?
Much simpler, generally. The sources talk about Firebase hosting, which is a PaaS platform as a service.
Okay.
That's specifically designed for web apps, works great with frameworks like Next.js. You basically point the Firebase tools at your code, and it deploys it, handling the underlying servers, scaling, CDN. A lot of that is automatic.
So no managing Linux VMs or Docker files yourself?
Not in the same way, no. Firebase abstracts a lot of that infrastructure complexity away.
And CI/CD. Still use GitHub Actions.
You can. Often it's GitHub Actions, calling the Firebase CLI their command line tool to trigger deployments. It's usually quite streamlined.
Okay, comparing this to the classic stack, wow. The convenience factor seems huge.
It is. You definitely sacrifice some of that granular control we talked about earlier. You're buying into the Firebase ecosystem.
But you gain speed and maybe reduce the operational headaches.
That's the trade-off. Precisely. You can focus more on your app's features, less on the plumbing underneath.
All right. So one end of the spectrum is classic, very integrated, is Firebase. Now, the next one, Next.js plus Vercel, sounds similar to the Firebase one, but maybe not quite.
You're right. There are strong parallels, especially on the front end. Again, Next.js 15 is central here. And Vercel, like Firebase hosting, is a PaaS.
Okay, platform as a service again.
And it's highly optimized for Next.js. Vercel actually develops Next.js, so the integration is incredibly tight. You get things like built-in CI/CD, often just by connecting your Git repository. Push code, it deploys.
And Vercel also has things like serverless functions, edge functions.
Yes, exactly. Ways to run back-end code without managing servers, often deploy geographically close to your users for speed. Vercel really excels at the deployment and hosting experience for Next.js.
But what's the key difference from the Firebase stack then? Is it the backend part?
That's the main distinction, yeah. While Firebase offers its own integrated suite of backend services, Firestore auth storage, Vercel's platform is generally more open or agnostic when it comes to choosing those backend services.
Oh, okay. So you deploy your Next.js app to Vercel, but you could plug in different things for the database or auth.
Precisely. You could still use Firebase's backend services if you wanted to, but you could also choose Supabase, which is like an open source Firebase alternative with a Postgres database, or AppWrite.
Or even just a dedicated database service like Neon or PlanetScale.
Yep. Or MongoDB Atlas. Vercel focuses on hosting the Next.js part brilliantly and lets you connect to various external or internal backend components.
So it's less of an all-in-one kit like Firebase, maybe more like a really good foundation and you bring your preferred backend blocks.
That's a great analogy. It's more modular in that sense.
Yeah.
For authentication, the sources mention using Nextauth.js, a popular library, or other external providers.
And Vercel's adding its own stuff too now, storage and databases.
They are. Vercel Postgres, KV, key value store,
Yeah.
blob storage. They're building out their own optional backend components too, giving you more choices directly within their ecosystem if you want them.
Interesting. So Vercel gives you that optimized Next.js deployment, speed, serverless features, but with more choice, more flexibility on the backend side compared to the Firebase bundle.
Exactly. It occupies a slightly different position. Still aiming for ease of deployment and developer experience, but maybe appealing to those who want to mix and match back-end tech a bit more.
Got it. Okay, let's switch gears significantly now, moving away from the JavaScript heavy world for a moment. The Python full stack?
Indeed. Python's obviously huge and very versatile for web development too. The sources point to a couple of main paths on the back end.
Which are?
Well, there's Django. That's described as like the mature batteries included framework. It comes with tons of stuff built in. An ORM, admin interface, auth,
ORM.
object relational mapper. It lets you interact with your database using Python objects instead of writing raw SQL. Makes things easier and more Pythonic.
Okay, so Django's the big established one. What else?
Then you have lighter weight, more modern frameworks,
Mhm.
often focused specifically on building APIs. Think FastAPI or Flask.
And they often get paired with a separate ORM, like Squalchemy.
Exactly. Squalchemy is a very popular ORM used with Flask or FastAPI to handle the database interactions. So Django bundles it. With Flask FastAPI, you typically add it separately.
Okay, that's the back end. What about the front end when you're using Python? Sounds like there are options there too.
Yeah, a couple of main routes. One is the more traditional server-rendered approach.
Meaning the Python server generates the HTML for every page.
Pretty much. Django has its own templating system, or you might use Jinja 2, coming with Flask. The server builds the page, sends to the browser.
But can those pages still be interactive, or are they just static?
You can definitely add interactivity. The sources mentioned using libraries like HTMX or Alpine.js. These let you add dynamic behavior like updating parts of a page without a full reload, often with minimal JavaScript directly in your HTML templates.
Interesting. So that's one way. What's the alternative?
The other main way is to build a completely separate front-end application, a single-page app, or SPA.
Using something like React or Vue or Svelte again.
Exactly. You build your UI entirely in JavaScript, and it just talks to your Python backend over an API. The Python app serves data. The JavaScript app handles all the rendering and user interface.
That feels like a pretty fundamental architectural choice. Server-rendered HTML with sprinkles of JS versus a full JavaScript front end talking to a Python API.
It is, and Python supports both models well. That flexibility is a key aspect of using Python for full-stack development.
And databases. What works well with Python?
Common choices mentioned are PostgreSQL and MySQL. Very standard, well-supported relational databases that integrate nicely with Django's ORM or Squalchemy.
Deployment. Similar options to the classic stack.
Kinda, yeah. You have the IaaS route, infrastructure as a service. That means setting up your own VM, maybe using Docker again, running your Python app using a server like Gunicorn or Uvicorn, and putting Nginx in front. Full control, full responsibility.
Or the PaaS app.
Or PPC, yeah. Platforms like Heroku, Render, Google App Engine, Cloud Run. These services handle a lot of the server management, scaling, etc. for you. Makes deployment easier.
And CI/CD with GitHub Actions is standard practice here too.
Absolutely. Automating testing and deployment is pretty much expected in modern Python development.
Okay. So Python feels really versatile. Powerful backend frameworks, plus choices in how you structure the front end and various deployment options.
That's a good summary. It offers a lot of pathways depending on your project's needs and team's preferences.
Right. Now let's talk about something with a very strong philosophy. Ruby on Rails monolith. The word monolith kind of gives it away, doesn't it?
It does suggest a more unified structure, yes. In this context, monolith typically means the front end and back end are more tightly coupled within the single Rails application, rather than being completely separate projects like a React SPA and a Node API.
And Rails is known for being convention over configuration.
Hugely so. That's its core philosophy. Rails makes a lot of assumptions and provides sensible defaults for how things should be structured and named. This aims to reduce boilerplate code and speed up development significantly if you follow the conventions.
It's also an MVC framework. Model View Controller.
Yes, a classic MVC pattern. Models handle data and business logic, views handle the presentation, usually HTML, and controllers handle user input and orchestrate everything.
And for the views, the HTML generation.
Traditionally, Rails uses server-rendered views, often written using ERB, which lets you embed Ruby code within your HTML templates.
But can it feel modern? Or is it just static pages?
But that's where things like Hotwire come in. The sources mention Hotwire, which includes tools like Turbo and Stimulus.
What do they do?
They allow you to build highly interactive, modern-feeling user interfaces with surprisingly little custom JavaScript. Turbo can automatically update parts of the page or handle form submissions smoothly, while Stimulus helps organize the small bits of JavaScript you might still need.
So you get some of the benefits of an SPA, like dynamic updates, but potentially without managing a whole separate JavaScript codebase.
That's the goal, yeah. It's an alternative approach to building rich interfaces that keeps things more integrated within the Rails monolith.
Interesting. And databases for Rails. Still the usual suspects.
Pretty much. PostgreSQL and MySQL are very common and well supported in the Rails world.
Deployment. PaaS seems like a natural fit for Rails.
Historically, yes. Platforms like Heroku and Render became very popular, partly because they made deploying Rails apps so easy. But again, you can deploy Rails on IaaS, VMs, Docker, if you need that lower-level control.
And CI/CD via GitHub Actions.
Standard practice here, too. Automated testing and deployment are crucial.
So that convention over configuration seems like the defining trait, potentially very fast development if you buy into the Rails way.
Definitely. For many types of applications, especially CRUD-heavy ones, create, read, update, delete, Rails can be incredibly productive.
But the flip side might be less flexibility if you need to do something really unconventional.
That can be the challenge sometimes, yes. If your app's needs deviate significantly from the Rails conventions, you might find yourself fighting the framework a bit, rather than flowing with it.
Makes sense. Okay, next up, modern PHP. Now, PHP, it sometimes gets a bad rap, doesn't it? But the sources suggest it's evolved a lot.
It absolutely has.
Yeah.
Thinking PHP is still like it was 15 years ago is a big mistake. Modern PHP, especially with top-tier frameworks, is a very different beast.
Which frameworks are we talking about?
The sources prominently mention Laravel and Symfony. These are mature, robust, feature-rich frameworks that provide excellent structure and tooling for building large applications.
Similar to Django or Rails in terms of providing structure.
Very much so. They handle routing, database access, often via ORMs like Eloquent and Laravel or Doctrine and Symfony, templating, security features, lots of things you need for a web app.
And the templating, generating the HTML.
Laravel uses Blade, Symfony often uses Twig. Both are powerful templating engines for generating dynamic HTML on the server.
And again, like Python and Rails, can you make these server-rendered apps feel modern and interactive?
Yes, several ways. In the Laravel world, there's Livewire, which is conceptually similar to Rails Hotwire or Phoenix Live View. It lets you build dynamic UIs with mostly PHP, minimizing JavaScript.
Or you could use a JavaScript framework.
Or you could integrate with Vue or React. There's a tool called Inertia.js that's popular in the Laravel community, which helps bridge the gap between a server-side framework like Laravel and a client-side SPA like Vue or React. It tries to give you the best of both worlds.
So definitely not just basic scripts anymore. These frameworks sound comparable to those in other languages.
They really are. The PHP ecosystem has matured incredibly. The tooling, the package management with Composer, the language features themselves, it's a capable modern platform.
Databases, same contenders.
Yep, MySQL and PostgreSQL are extremely common with PHP frameworks.
And deployment. IaaS and PaaS again.
Both are viable. You can run PHP on a VM with Nginx and PHP FPM, the process manager, or use paid options. Heroku supports PHP well, and there are specialized platforms like Laravel Vapor, which is a serverless deployment platform for Laravel built on AWS Lambda.
CI/CD with GitHub Actions.
They're going very standard in the modern PHP world, too. Automate all the things.
Okay, so the surprising fact here is just how far PHP has come. It's a genuinely modern, competitive option with frameworks like Laravel and Symfony.
Absolutely. Anyone dismissing PHP out of hand based on old experiences is likely missing out on a very productive ecosystem.
All right, this next one sounds really different conceptually. The JAMstack Plus stack. What's the core idea here?
JAMstack stands for JavaScript, APIs, and Markup. The fundamental shift is moving away from a traditional web server that dynamically builds every page on request.
Okay, so what does it do instead?
The core idea is to pre-build as much of the site as possible into static HTML files. That's the markup. These files can be served incredibly quickly from a content delivery network, CDN.
Static HTML, like a website from the 90s. How does it become an application?
That's where the J&A come in. Any dynamic functionality is handled by client-side JavaScript running in the user's browser.
And where does that JavaScript get data from if there's no big backend server?
From APIs. The JavaScript calls out to various external APIs or backend services to fetch data, handle user authentication, process payments, perform searches, whatever is needed.
So you might use what kind of tools to build the static markup?
The sources mention static site generators, SSGs, things like Next.js and its static export mode, Astro 11D, Hugo. These tools take your content and templates and compile them into optimized static files during a build step.
And the plus in JAMstack. Plus, what's that about?
It sort of acknowledges that modern JAMstack often involves more than just static files. It leans heavily on that client-side JavaScript interacting with a rich ecosystem of services.
Like backend as a service again, Firebase, Supabase.
Exactly, or specialized APIs. Auth for authentication, Contentful or Sanity for content management, Algolia for search, Stripe for payments. You compose your backend from these discrete, often third-party services.
So for our ebook app, the book listings, maybe the covers, could be pre-rendered static markup for fast loading.
Precisely. Super fast initial load. Then JavaScript would kick in to handle the add to cart, login, maybe fetching personalized recommendations from an API.
And deployment sounds different too, not VMs or typical pails.
Often, yes. You deploy these static assets, HTML, CSS, JS, to specialized static hosting platforms. Netlify, Vercel, again, Cloudflare pages, even Firebase hosting static option.
And these platforms often have extras, like serverless functions.
Yeah, that's key. If you do need a little bit of back-end logic, maybe to process a form submission securely or interact with a protected API, these platforms usually offer integrated serverless functions or edge functions, so you don't have to manage a separate back-end server just for those small tasks.
And CI/CD? Is it built in?
Very often, yes. These platforms typically integrate directly with Git providers. You push your code, they automatically run the build process using your SSG and deploy the resulting static files and functions. Super smooth workflow.
Wow. This feels almost backendless in a way. Or maybe a distributed backend.
Both are good ways to think about it. You're pushing logic to the client, JavaScript, and leveraging specialized distributed services, APIs. It's a very different architectural pattern.
What are the big advantages? Speed? Scalability?
Performance and scalability are huge selling points. Serving static files from a CDN is incredibly fast and scales massively, almost automatically. Security can also be simpler as there's less server-side code vulnerable to attack.
Any potential downsides? Managing all those APIs?
That can be a complexity, yeah. You might end up orchestrating calls to many different third-party services, each with its own quirks, rate limits, and billing. Vendor lock-in can also be a concern if you rely heavily on specific proprietary APIs, and build times can become long for very large sites.
Fascinating, a really different perspective. Okay, one more stack to cover. The ASP.NET Core stack. This takes us into the Microsoft ecosystem, right?
It does. ASP.NET Core is Microsoft's modern, open-source, cross-platform framework for building web applications, APIs, and more, primarily using the C# language.
And it seems like there are different ways to build UIs with it.
Yes, the sources mention a few patterns. There's the traditional MVC, Model View Controller, which is very common for web apps. There's Razor Pages, which is maybe a simpler page-centric approach for some types of apps.
And Blazor, that sounds interesting. C# in the browser.
Exactly. Blazor allows you to write interactive web UI components using C# instead of JavaScript. It can run the C# code directly in the browser using WebAssembly, Blazor WebAssembly, or run it on the server and communicate with the browser over a real-time connection, Blazor server.
So C# developers can potentially build full-stack applications without switching languages as much.
That's a major appeal of Blazor, yeah.
Databases. Is it mostly SQL Server?
SQL Server, Microsoft's own database, is obviously a very common and tightly integrated choice. But ASP.NET Core works excellently with other databases too, like PostgreSQL, MySQL, SQL. It uses an ORM called Entity Framework Core, which supports many database providers.
Where do you typically deploy ASP.NET Core apps?
Azure, Microsoft's cloud, is a very natural fit. Services like Azure App Service or Azure Kubernetes Service are popular. But because it's cross-platform, you can easily deploy ASP.NET Core apps to other clouds like AWS or Google Cloud, either on VMs or using Docker containers on Linux or Windows.
And CI/CD, Azure DevOps.
Azure DevOps provides a very integrated CI/CD experience within the Microsoft ecosystem. But again, GitHub Actions is also a very popular and fully supported option for building and deploying ASP.NET Core applications.
So this feels like a very robust, maybe enterprise-focused stack. Strong tooling, good performance.
That's a fair characterization. ASP.NET Core is known for its performance, scalability, and the strong tooling support from Visual Studio and the .NET ecosystem. It's widely used in enterprise settings, but is perfectly suitable for smaller projects too.
Wow. Okay, we have really covered a lot of ground here, from the classic containerized control to the integrated speed of Next.js plus Firebase, the adaptable Next.js plus Vercel.
The versatility of Python, the convention-driven Rails monolith, the surprisingly modern PHP stacks.
The decoupled performance of JAMstack plus Cell, and the enterprise strength of ASP.NET Core. It seems, well, abundantly clear there's no single best answer.
And that's really the absolute crucial takeaway, isn't it? The
Yeah.
choice isn't about just picking the shiniest new technology. It's a complex decision.
Based on what, mainly?
Well, the sources implicitly point to a bunch of factors. Like, what does your team already know? Are they JavaScript wizards, Python experts, C# gurus? Team expertise is huge.
Makes sense. Use what you know. What else?
The specific needs of the app itself. Is your ebook platform going to have super complex business logic and data interactions?
Yeah.
Or is it more straightforward, maybe leaning heavily on content delivery?
Right. Does it fit well with a BaaS model, or do you need custom backend stuff?
Exactly. And scalability. How many users do you realistically expect? 10, 10,000, 10 million. Different architectures scale differently.
And that control versus ease of use thing we kept coming back to.
Definitely. How much infrastructure do you want to manage? Or how much are you willing to pay a platform to manage for you?
So each stack has its own profile of trade-offs.
Absolutely. More control usually means more responsibility, more operational work. More convenience might mean less flexibility or potential vendor lock-in down the road.
And all these choices impact things like how fast you can build, how the app performs, how easily it scales, and of course, how much it costs to run.
Which kind of leads us to the big question for you, the listener, really. Having heard about all these different ways to build an online ebook app, what do you think matters most?
So, yeah, you've just finished this deep dive, this snapshot of a really diverse technology landscape for just one type of application, an ebook platform.
We really hope that digging into these different approaches gives you maybe a richer appreciation for what goes on under the hood.
All the complexities, the decisions that go into building the software we interact with every single day.
And as you mull this over, we'll leave you with this final thought to ponder. When you consider things like, say, the speed of getting something launched versus its ability to scale up to potentially millions of users versus the ongoing running costs,
What aspects do you think would be the most critical factors in picking the right technology stack to build a truly successful ebook platform?
something to think about as you continue exploring the world of technology.